Welcome to the Femap version 11 What's New video series. In this video we'll be looking at several Femap enhancements that support NX NASTRAN capabilities that have been introduced in recent releases, and which serve to strengthen Femap NASTRAN integration. Femap now supports the NX NASTRAN solid composite element, including the pcomp-s physical property for hexa and penta elements, and the mat-ft definition for failure theory material constants. Solid composites offer a more geometrically precise representation and a more accurate interlaminar shear stress calculation than the 2D laminate model. The ply layup is modeled with solid hexa and penta elements, with ply thicknesses defined in relative terms with respect to the element laminate thickness dimension. Preloaded bolts can be modeled directly using solid hexa and penta elements, giving greater stress recovery detail in and around the bolt connections. The linear contact definitions can be set up with additional regions for the preloaded bolt cross-sections, together with a preload loading case. NX NASTRAN initially performs an interim solution to calculate the stress state resulting from the bolt preload forces, before going on to solve the service load cases if required. You can define non-structural mass regions to represent portions of the model that have significant mass which act independently of the structure, like fuel loading in this wing model, for example. The mass regions can be based on geometry, curves and surfaces, or elements, beams and shells. The mass can be defined per area or length, or as a total amount. Because the mass regions are controlled within subcase level, you can switch them on or off like load cases and analyze the effects of differing mass distributions on the model in a single run. Femap now supports the NX NASTRAN AXAL acceleration load definition. This method of applying acceleration loading allows you to define different acceleration loads over different parts of the model directly. These loads are created through the body load creation dialog and reference an acceleration versus location type function to define the acceleration magnitude and distribution. This capability makes it much easier to define distributed acceleration loads across the model and combine rotational and translational accelerations. For 2D orthotropic composite materials, you can now define the material angle using a coordinate system ID. This makes it a lot easier to align many elements to one material direction, regardless of the element's orientation or connectivity. The x-axis of the referenced coordinate system is projected onto the elements, and defines the x-axis of the material coordinate system for that element. This also means that cyclic tests are honored, that is, models imported that have material angles defined using a coordinate system ID will be written out in the same manner. Femap supports linear contact with buckling. You just need to set up the contact regions as usual with the applied load and constraints, and select buckling as the solution in the analysis manager. Femap will write out the deck with contact regions for NX NASTRAN to perform a buckling analysis. Post-processing will reveal the buckling eigenvector and eigenvalue according to the loads, constraints, and contact regions that have been modeled. Note that these are only some of the new features that support Femap NX NASTRAN integration in this release. For full details, please refer to the release documentation. To find out more, visit us at siemens.com/plm/Femap or call your local channel partner.